Hi, welcome to Math 120 Intermediate Algebra. This is for Math 120 at Doña Ana Community College. I swear I could pronounce that. Also, NMSU. This textbook is Turner McKeague through XYZ textbooks, but it's helpful information for anybody that needs to know about real numbers, section 1.1. Alright, so let's start with a number line. We're going to take any line, and we'll mark a 0 someplace convenient. Frequently I'll put it in the middle, but it's an infinite line, so middle is kind of a weird thing to say. So here we have a 0, and then we're going to use positive numbers counting up, and negative numbers counting down. And this number line is kind of the basis of a lot of what we do. Keep in mind when you're writing numbers, you always want to go from least to greatest, always from left to right. Smallest values to the left, larger numbers to the right. And so in this whole idea of left and right, we have some notation. We use the following inequality notation when comparing two numbers. The symbol A is less than B indicates that A lies to the left of B on the number line. In words, we say A is less than B. So the symbols with the words. We could put a line underneath this, and then it would be less than or equal to. But for me, the key is here. Left of, less than. Both have L's, and if you write sloppy, that kind of looks like an L, so that's how I remember it. Whatever works for you, use it. It doesn't matter if it's juvenile or not. Here we have A, and then a different symbol B, and this symbol indicates that A lies to the right of B on a number line, and we say that A is greater than B. Again, we could have a little line underneath to make it greater than or equal to, but it's the same idea. It's still to the right of B. The number associated with a point on the real number line is called the coordinate of that point. Right, it's where it's located. It's coordinates. Think of it as GPS coordinates, only it's on a number line instead of out in the middle of the desert somewhere. The numbers that can be represented with points on the real number line are called real numbers. And in this class, we're going to stick with real numbers for the most part. There'll be a couple of sections we talk about other types of numbers, but we'll get to that when we need to. If A and B are real numbers, so anything you could find on the real number line, as long as B is not 0, it could be anything else, then the expression A over B is called a fraction. The top number is the numerator, and the bottom number is the denominator. So whether you think of top and bottom or numerator and denominator, notice that bottom comes first alphabetically in its pair, denominator comes first alphabetically in its pair. So we could all remember top and bottom, but learn the mathematical terminology, numerator and denominator. This fraction, keep in mind, B can't be 0, so the denominator can't be 0. Otherwise, that's all it is. So looking at fractions, we have many different ways of writing the same number when it comes to fractions, and these are called equivalent fractions. So if I have 1/3, that's the same as if I took a number line and I cut it into sixths. There would be 2/6 is the same as 1/3. If I cut the number line into twelfths instead, 4/12, the same as 2/6, the same as 1/3. They might look different. They have different numbers representing them, but they're all the same value. Let's take a look at how we could write equivalent fractions. Here's a property for us. Multiplying the numerator and denominator of a fraction by the same non-zero number results in an equivalent fraction. So if I have 7/9, and I want to rewrite it with a denominator of 27, I know that 9 times 3 is 27, so I multiply both numerator and denominator by the same non-zero number. So I multiply both numerator and denominator by 3, and now 21/27 is an equivalent fraction to 7/9. That's all it takes to write an equivalent fraction. Another property we have is that any two real non-zero numbers the same distance from 0 but in opposite directions from 0 on a number line are called opposites or additive inverses. Now that sounded a little complicated, so let's take a look. If I have a number line and I have my 0, maybe over here I have 3, maybe over here, the same distance away, I'll have negative 3. So any two real non-zero, so not this one, here's a non-zero number. It's the same distance from 0 as its partner over here, negative 3. Opposite directions, one's to the right, one's to the left. They're called opposites or additive inverses. I should use the term additive inverses, but I will frequently use the term opposites just because it tells us more about it. So if x is any real number, it doesn't have to be 3, then we denote the opposite of x by negative x. So the opposite of 3 is negative 3. Absolute value. Now, geometrically, the absolute value of a real number is its distance from 0 on the number line. So the number 3 is 3 units from 0 on the number line. The number negative 3 is also 3 units from 0 on a number line. If x represents a real number, then the absolute value of x is written with these lines, absolute values. Keep in mind that the output of the absolute value is never negative. It's a distance. Now, algebraically, if x represents a real number, then the absolute value of x, also written with the bars, it's given by what we call a piecewise defined function. So the absolute value of x is just x as long as x is greater than or equal to 0. So if x is 0, the absolute value of 0 is 0. If x is 7, the absolute value of 7 is 7. Now, if your input is less than 0, this is our domain restriction here, so if your input is a negative number, so the absolute value of negative 7 is less than 0, and so I change the sign, it's the opposite. So the negative of negative 7 is positive 7. The result will always be non-negative. Prime numbers and factoring. If a and b represent integers, and integers are the positive and negative counting numbers along with 0, then a is said to be a factor or divisor of b if a divides b evenly. So that is, if a divides b with no remainder. So for example, I know that 3 is a factor of 12 because 3 goes into 12 exactly 4 times. When I take my factors 3 and 4 and I multiply them, I end up with a product of 12. If I take 12 and I want to find its factors, I go back to 3 times 4. So the result of multiplication is a product. When I'm splitting multiplication apart, I'm factoring. So what is a prime number? A prime number is any positive integer larger than 1, so it has to be a positive integer, so we're looking at counting numbers, larger than 1, whose only positive factors are itself and 1. This is not a negative sign. This is instead of a dot, it's just a dash as a listing. So 1 is not a prime number because it has to be larger than 1. So the first prime number is 2. 2 is the only even prime number. Some of the following numbers, all of the following numbers are primes, and they're all the primes up until 41, and you could keep going. There's something called the sieve of Eratosthenes. There's a great way for generating prime numbers. That's the sieve of Eratosthenes, if you want to look it up. Any any integer greater than 1 that is not prime is said to be composite. So 2, 3, 5, these are prime. 4 is not in the list. 4 is not prime. 4 is said to be composite because we can make 4 as 2 times 2. Alright, so the only positive factors are itself and 1. The only way to get 13 is 13 times 1. The only way to get 17 is 17 times 1. But 16, we could get a 16 times 1, 2 times 8, 4 times 4, many different ways to make our composite values. Alright, so let's factor into a product of primes. I always start simple. If I have a 34, I see the 4 at the end, I know it's an even number, so I know it has a factor of 2. So looking at 34 equals 2 times 17, I look at 2, I know that's a prime number. 17, also a prime number. I've factored 34 into a product of primes. It's not always that simple though. Sometimes it goes a little further. Let's take a look at 216. So 216 is an even number, so I know that's 2 times 108. Now 2 is a prime number, so I'm going to leave that. But 108, also an even number, can be factored. And 2 times 54 is equal to 108, so this same 54 can now be factored as 2 times 27. This 27 I can now factor as 3 times 9. It's no longer even, so I can't put a negative number into it. Excuse me, I wouldn't use a negative number anyway. It's no longer even, so I can't put a 2 into it. Now I look at this 9, because I know 3 is a prime number. 9 factors is 3 times 3. And now every single value I have here, 2, 2, 2, 3, 3, 3, they're all prime numbers, and so I might write them with exponents. 2, 2, 2, I can call that 2 to the third power. 3, 3, 3, I call that 3 to the third power, and I have factored 216 a step at a time down to a product of primes, 2 to the third times 3 to the third. Last thing we're going to talk about in this particular lecture is any two numbers whose product is 1 are called reciprocals, or multiplicative inverses. So if you have any number, maybe you have 3/4. The product of 1, its reciprocal, is going to be what we get when we flip the fraction upside down. Multiply fractions straight across. So we know that these two are reciprocals because their product is 1. Informally, if A over B is a real number, then B over A is the reciprocal. This ends the first lecture.